All right, let's actually implement that GoldStar database that we normalized in Excel in Access. So if you watched this video previously, you probably already have it open, but if not, go ahead and download this material again one more time here. And we're also, let's try that again. There we go. And let's also open up Microsoft Access. Get that going as well. All right, open up GoldStar. So if you remember, whoops, open it up a few times. Close. Okay, so if you remember, we left off, we had taken this unorganized data with lots of redundancy, and we had split it apart into 3 tables and added primary keys and foreign keys to connect the dots among the information. So now let's go ahead and open Access, and we need to do a few things. We talked about business critical integrity constraints, the idea or the process of making sure that if someone goes to enter data in a field, like for good old Harold Foster here, we do all we can to make sure that what they enter is correct. For example, we don't allow text to be entered into a field that should only be numeric. We don't allow a social security number to be entered if there's already one. Where'd she go? There we go. If there's already one in there with that same social security number, this field is the primary key, therefore everything must be unique. So we can add these integrity constraints. Let's go ahead and I've got parallels running here because I'm on a Mac. Let me make this window a little bit smaller, hopefully. Trying to, come on. All right. Move, no, stop, easy windows, right there, right there. Beautiful. Sorry that took so long. Okay, I'm going to make a blank database in Access. First thing you'll notice here is that before I can do anything, it wants me to save the database file. Interesting. This is difference number 1 between Access and something like Excel or Word. So Excel and Word, when you create a new file, you're creating this in your computer's RAM. Hopefully you remember where that is from chapter 2, or the first section. RAM is volatile, meaning it goes away when the computer is shut off. But it's fast and it's quick. It's kind of like your desktop, or I mean the top of an actual physical desk. We pull our stuff out to work on top of the desk, and let's assume it's all going to be dumped and thrown in the trash at the end of the day. So if we want to keep anything from the top of the desk we've worked on, we have to put it back in the drawers. So Excel and Access work like that. They work in your computer's RAM. You create a file, you edit it, and if you want to keep that file, you're going to have to save it, which copies it to your hard drive so that you can have it permanently. Access says you can't even get started on the desktop. You've got to save this thing into the desk or onto your hard drive immediately. That's because a database is intended to be shared by many people at once. So when you edit a database, or when you edit specifically the data in databases, you are writing directly to a hard drive. That way, you don't overwrite other people's edits, and other people don't overwrite your edits, and you can all see the most updated data when you share a database file. So it says before you can go any further, make sure you save a copy of this somewhere. So I'm just going to call it GoldStar example, demo, whatever you want to call it. Go ahead and create it. And I'm going to leave it just like this. We'll come back to this in a second. So let's take one more look at GoldStar. We're going to make 3 tables, one for employee, office, and position. All right, let's go to Excel. There's a few ways we can do this. Now there's the lazy man's way, which, well, let's just show you that one first. I'm going to copy this whole table and all the data in it. Command-C or Control-C, depending on what you're in. I'm going to come back here and I'm going to change this view, name this table as employee. Actually, no, sorry, I like that view that I was in. I'm going to click up here in this upper corner and I'm going to hit Command-V to paste it. So you're about to paste 25 records. You sure you want to do it? Yes. These records are now written to the hard drive in a table called employee, and it made these field names for me across the top. All right, that's one way to do it, one quick way to do it, but that's actually, well, no, we'll keep this one this way, and I'll make the other tables more traditional way. So here we have the option to change the view from datasheet to design view. So being a real relational database management system, Access has a whole ton of features that enable this to be good data. One of those features is to go and look at this design view of a table. So imagine taking this datasheet view and flipping it counterclockwise 90 degrees to where these field names across the top are now down the rows. And I have information about each of these rows right here. So it took its best guess. For some reason, it named this ID instead of social security number. I want it to be SSN. I like that. Okay, the data type. It made it, each field is going to have its own data type. If you remember from that previous video, I said that databases can save space if it knows that the data in a field will always be numeric, like salary. This will take up a lot less room than if I make this short text or long text or time or something like that. The smallest data size is yes, no, or a single bit. That means the field can only have two values, true or false, 0 or 1, yes, no. We use that for a field like, imagine in an orders table, a field called shipped, meaning has this order shipped or not. So if we make that a yes, no, it uses only 1 bit for every cell in that field for the space. So to the degree possible, we always want to be very specific and use the smallest data type that we can for field. Anyway, social security number, auto number, what that means is, first of all, look at this little key right here. Tiny little key. That's what's marked this field as the primary key. I can turn that off right here with this button, say no, it's not a primary key, or turn it back on. Now if I turn it on, it's going to do a quick look and say, is everything in that field unique? Oh, and look, it overrode it as numbers. Did I do? Oh, I know what happened. I'm going to delete this guy from right here. You know what I did wrong? Delete. There we go. You can't delete it? You're trying to tell me what I can't do? Well, I can't delete it while it's open. All right. Close. Thank you. Now deleted. Yes, deleted. I keep forgetting that this view is only... No, I did copy social security number. Why didn't it include that? Let me try it again. Command C. Let's come back here. Let's go and create a new table. Oh, it already had a field called ID. That's part of the problem. Let's see if it lets me do it now. Nope, it didn't. I bet there's a way around that. Don't do that. No. Let's try it one more time. No, it didn't like it. There's got to be a way to get that in there. I'll worry about it later. For now, what I could do if I wanted to keep that, for example, and not lose the not use the social security number, I can come back to my design view. Yes, save this as employee one more time. And I can insert a row right here, call it SSN. This is going to be, actually I've got dashes in it, so I can't call it a number. I'm going to have to call this, for now, short text. I can come back here, copy all this stuff, Command C, flip the table, yes, save my new social security number, and see if it will let me paste down the rows. You can let me do that? I'm guessing not. No, it did. Hooray. There we go. But I get the feeling, did I get Jennifer Adams wrong? Oh, no, that's her social security number. Yep. All right, so I can paste data in that way. If I want to, I can come back here and say, no longer make that a primary key. Let's kill that. But, well, I'll come back to that later. And then make SSN my primary key. There we go. All right, but I've got some other tricks up my sleeve here that will help make sure our data is clean. Change the data in the field that contains duplicate data. Oh, do I have repeated primary keys? It won't let me save that. Save it, but it won't let me do it. All right. Undo my changes. No, don't save the table. Go back. Now it's really mad at me. I think I must have had, oh, you know what? I had repeated social security numbers, right? So it says you can't make that a primary key because Harold Foster is the same as Emily Wood. So I've got to go back. No, I'm going to make this not a primary key. Save it now. There we go. Now it's happy. And I got to make sure every one of these is unique. Harold Foster, let's change him to a 4, 4. All right. Data's changed. Make this guy primary key again. Let's save it. There we go. Now everybody's happy. So see how it made sure it wouldn't let me make this a primary key because it said you've got duplicate values in it and it can't be a primary key with duplicate values. That's a business critical integrity constraint. It's making sure that the data I have in here is valid. So I would have had to look up and make sure that I had those right. All right, so notice I've got salary here made as a number. Let's go back. Let's try and add a new row. That's what this one's for down here. The star means here's where you come to add something new. Let's just put something in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Watch me have something like that somewhere else. Nope, it's unique. So let's put my name in there. Let's try and give me a salary of 1 million. Oh, look at that. The value entered does not match the number data type in this column. This is a business critical integrity constraint. Not going to let me screw things up. All right, let's enter a new value then. There we go. That's more like it. Male performance rating is excefabulastic. Okay, where do I work? I don't know. I don't even remember what one is. Atlanta. And I'm number 1. There we go. New field created, and it made sure that I entered the right stuff. All right. But hang on. I don't like FK being a part of the field name. Delete. Delete. There we go. That's better. Anything else we can change? How about gender? All right. Gender, we only have 2 types. So should we leave it as short text? Nope. Whether people identify as one or the other, we're not going to get into anything more complex than 2 types. We're going to stick with yes, no. And then if we go back here, save the table. Okay, some data may be lost. It says, you sure you want to do this? Yes, go ahead and do it. It says the contents in those fields were deleted. That's because we had M and F. And that's not going to work with the yes, no data type. Let me show you what it looks like. We get a checkbox. So check means 1 or true. Unchecked means 0 or false. Well, you can't. Gender isn't a true or a false thing. We just have to decide, what does a check mean? Let's say that check means female, and I'm just going to guess here based on names, which is terrible, I know, but it's all I can do at this point. Let's see, females: Sandy, Sue, Marietta, Holly, Patricia, Melissa, Heather, Kelly. Beautiful. What we're going to do now is go back into the details. In our notes, we're going to say yes equals female, no equals male. And that's what this description is for, is to simply say, all right, we decided to code this in a way that would save us some space. Here's how we interpret it. For example, we could do that with performance as well. What if I come back here, save the table, yes. What are my possible scores? Average, good, poor, and then, of course, excellent, fabulastic. So it looks like normally, though, I only have 3 options. So here's what I'm going to do to save me some space. I'm going to say that this is now, well, I better switch it. Average is now going to be 2. Good is 3. Mine obviously is 4. 3, 2, 3, 2, 3. Poor will be 1. 3, 3, 1, 3, 2, 1, 3, 2, 3, 1, 2, 3. There we go. And now let's change performance to numeric number. And I just come here to my notes. I say 1 equals poor, 2 equals average, 3 equals good, 4 equals mark. There we go. Okay, and that's how I save space in my database. Now you may say, all right, how much space is that really taking? All right, you're right. Unless I've got millions and millions of employees, I'm really not saving myself a whole lot of space by doing that. However, think of Walmart and their transactions. Okay, they do millions and millions every day, so they must use numbers wherever possible to keep things nice and small. All right, let's add our other tables in here, but let's do it differently. This time, let's go to Create, Table, and let's enter things in one at a time. So instead of using this view, I'm going to go ahead and switch over to my design view. I'll change this to my office table. But if I could spell office, that would be even better. Because I'm obsessive compulsive, I'm going to go ahead and do that. Rename. All right, office view. Here we go. All right, let's look at the fields that I have. I've got loc ID. Here we go. Loc ID. I'm going to leave this as an auto number, and I told you I was going to come back to this. I'm going to show you how this works here in a sec. Next, I need location, city, address, date, zip, office, phone. Now, I like to get rid of spaces. It's not necessary. Access will handle spaces, but other database management systems won't. It'll force you to get rid of them. So To make this compatible with other environments, let's just go ahead and kill all spaces and field names. So location city, what should that be? Number, short text. Hopefully you can realize that's got to be a short text. Let's see, address, also going to have to be short text. Let's see here, state, zip, and office phone. State, short text, zip. We can make this a number, and office phone. I propose we also make that a number, and then just kill all parentheses, dashes, and all that to save ourselves some space. All right, so we can do a few things to make this even better and more likely to give us good data or be smaller. For example, state, we could use a code. So down here we have more details, field size, format, input mask. Now hopefully you've learned about these in a previous class at some point, but they're pretty easy to look up. All I'm going to do is, I'm not going to spend a lot of time going into detail. I just want you to remember that you need to use these whenever possible. For example, field size, I'm going to make 2, because for a state I can just use an abbreviation. So format, I can specify capitalization. Input mask, I can auto capitalize things to look however I want to. Default value, if someone doesn't enter a state, let's say for example I'm based out of California or wherever, I can say the default value is CA. If they forget to enter it, if they don't enter it, they're just saving time because 99% of our workforce is in California. I can do that. Required, do they have to enter this to enter in a new location? So I can not even let them add anything at all unless they add this, add a value for state 2. Now you'll notice that primary keys are always required. It doesn't even give me the option to make it required or not because it has to be required. Everything else though, I get this option for required. Notice I also get different options whether it's a number or a short text. So a number, zip, I have different types of numbers. Byte, I can make it a 0 or 1. Another way of getting at that yes, no. Integer, long integer, this is how many digits can be in there. Zip, I think integer will handle 5 numbers. So we're going to stick with 5, we'll try it out. However, office phone, I think is going to need to stay as a long integer because that's 10 digits, and I think that's a bigger size. Single or double, if you're a programmer, you're more familiar with these types of data types. Again, it's just how many digits can there be in the number. Does it allow decimals or not? I think I'm going to leave the rest like that. Validation rule, okay, what would this be? I can put a rule in here, for example, that says for zip, I got an idea, validation rule, it must be greater than 0. All right, in other words, I can't put in a negative zip code. May as well put that in for office too. I can't imagine why anyone would try that, but just in case they accidentally hit, who knows, something stupid, then that's one way of validating and making sure you add, add extra business critical integrity constraints. All right, so what we can do now, save the table. Here's our data. Let's just copy. Oh, let's add one in here. I'm going to put in, watch what happens, at land. As soon as I start typing, notice it put the number 1 right here because the field type is auto number. It's going to look at whatever other data is in the field, add 1 in the table, add 1 to it, and then proceed. So because there were no records, it made this one number 1. So there was some address, state. What if I try and type more? Look how it won't even let me go past AA. All right, so I'm in Utah. Zip, let's put in -45, or whatever that is. Nope, you can't do negative. All right, fine. 84604, whoa, number lock. Sorry, 84602. Oh, isn't valid. So integer must not be big enough to handle that. I think I'm going to have to go back and change that. Let's see if it'll handle this one. Yep. I'm going to have to change zip back to long integer. Office phone, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There we go. And now notice when I add another one, Chicago, see how it automatically made this number 2, and I can proceed. So let's come back here and actually just copy this data right here without the location ID because it will automatically put those in. Okay, we got it. Let's escape out of that. And I'm going to go right back here and command, will this work? No, let me do that. Let's try again. No, it doesn't like that. Let me not include Atlanta and see if I can copy paste this way. Let's go right here and paste. No. Oh, come on. Looks like I'm going to have to enter them in all by hand. That's okay. I wanted to show you how to do this. So this is how you enter things in all by hand. Because I'm lazy and I don't have to do it again, I am going to close it. Okay. Okay. Close it. I'm going to delete this guy. Yes. Delete it. Go for it. And then I'm going to do it the lazy man method just so I can hurry and get to the last thing I want to show you guys and ladies. Okay, let's click up. Oh, don't do that. Click up here, paste. Why did I open that? Kill that. Yep, paste the records. What happened to my stupid, come on. All right, insert filled. Change this. This is office filled. Oh, I see what the problem is. Hold on. Here I am creating problems. Close, delete. I forgot to copy the field names. Let's try this one more time. Create table. There we go. Let's get field names in there. See if it'll let me do all this. Command C. Try again right here. Command V. Yes, paste these records. The only thing it didn't do is, once again, it called this ID. Let's go back. Call this office. Change this to loc ID. Yeah, it doesn't have all my cool stuff in there to validate it, but whatever. Save. We're good. Create one more table. Back here, let's grab positions. Command C. Paste. Yes, call this position and change this to POS ID, position ID. All right. Save away. All right, we got our 3 tables. What do we need though? In employee, we do have our foreign keys right here. We're not quite done. There's one more really cool thing I want to do before we're done with this chapter. And we're going to explore this over the next 2 to 3 days. So go here to Database Tools, Relationships, and it says, here's tables you have that you could create relationships among. I'm going to select all of them and hit Add, Close. You can always just click and drag them onto here like this. Anyway, I'm not going to do that right now. Or I'm going to get rid of that one. All right. So here we have a visual diagram to represent all the field names in each table. What I want to do is tell Access how these tables are related. I'm going to grab locID here and drop it on locID in Office. And it says, what's the relationship here? Well, I'm going to check this box. It says enforce referential integrity. What that means is if someone were to create a new employee and put a location ID that doesn't exist as a location ID in this table, it won't let me do it. It's another integrity constraint. It'll say, sorry, there's no such location as number 10 or whatever it is. Enter in something valid. By unchecking it, it will let me put something here that doesn't match up over there. So this is a smart thing to do. Now, this next part is up to you. Cascade Update says that if I were to change an ID in Office, it'll automatically update all of the matching IDs to the new number over here. Delete, if I delete an office, it'll automatically delete all employees in that office over here. So this can be useful in some scenarios, but not always. So use these with caution, but use this one. Should be almost every time. All right, create. Now there's some notations here that we're going to learn about over the next couple of in the next chapter, so I'm not going to get into them right now. But instead, I'm going to grab. Let's make this look nice and pretty. All right, let's grab position ID, drop it on position ID. Same thing, enforce, create, voila. This is a database diagram. We'll talk about this more later, but I'm going to save it now, just like that. Close it, and now let me show you something kind of cool. I open the Office table. What is different? Look right over here. We have plus signs now. Click on that, and it says, look, here's all the people in your Atlanta office. We noticed you created a relationship between location ID of this table and location ID in this table. So we don't even show location ID right here because we already know that these are all the employees in location 1, and we're going to match them up for you. So there's some cool features from creating those relationships inside an actual relational database management system like Access. All right, that's all for this chapter. Nice crash course on databases. Take the quiz and get ready to learn ERD in the next chapter.